You are welcome to today's class with your usual teacher, and called Christopher Ejike, your chemistry teacher. You are welcome to today. Let's enjoy the class together. I want to begin by asking you, how does water form? What actually make up the water we do drink, or water molecule? What makes it up and how does it form? Water is formed when two molecules of hydrogen combines with one molecule of oxygen to produce two molecules of water. Now, if two molecules of hydrogen joins with one molecule of oxygen, it produces water. By that implication, water does not form when four oxygen joins with one hydrogen. No. By this, it's telling us that there is a proportion of oxygen needed to combine with a proportion or some proportion of hydrogen to produce water. Or we can put it in this way. There is a volume of water, the quantity of water needed to join with the quantity or volume of oxygen in order to produce water, we do say. And there is a man that investigated this and postulated it, which name is GAY-LUSSAC. This will lead us to what we have or the topic of today, which is GAY-LUSSAC law of combining volumes. The topic of today's class is GAY-LUSSAC law of combining volume. What does GAY-LUSSAC say about combining elements, combining to another element to form a particular compound? GAY-LUSSAC law of combining volume states that when gases react, they do so in volumes. When gases react, they do so in volume, which are in simple ratios to one another and to the volume of the products, if gaseous, provided that temperature and pressure remains constant. I said once again that a man called GAY-LUSSAC proposed a law which is being tagged as GAY-LUSSAC is the one that actually found it out or postulated it. We call it GAY-LUSSAC law of combining volume. The law states that when gases react, they do so in volumes which are in simple ratios to one another and to the volumes of the products, if gaseous, provided that the temperature and pressure remain constant. This man, just like the issue or the example that of what brought us to this topic, issue of water, formation of water, or even formation of steam. Steam is just a gaseous water. Between the reaction of water, oxygen and hydrogen, this man found out, he postulated and he said that water is formed when a certain volume of oxygen reacts with a certain volume of hydrogen, or when a certain volume of hydrogen reacts with a certain volume of oxygen to produce water, even a certain volume of water. Now he says that they are in volume. Those volumes are in ratios, meaning that, as we can see, that when two volumes, which is normal reaction, we call it two atoms of hydrogen, react with one atom or one volume of oxygen, it produces two atoms or two volumes of water. In ratio, it's just for you to put it in ratio that for water to be formed, we have 2:1:2, meaning hydrogen 2 volumes, water, oxygen 1, and water formed is also 2 volumes. look at that ratio. It means that for reaction to occur, there is a certain volume of oxygen needed to react with a certain volume of hydrogen to produce a certain volume of water. With this example, meaning that if we have one volume of hydrogen, it means that half of oxygen will be required to produce one volume of water. Get me? By this equation or by this definition, it means that if one volume of hydrogen goes into reaction with oxygen, what the number of oxygen or the volume of oxygen that will be required will be half, and the amount of water that will be produced will be 1. So the quantity of hydrogen required by volume is the same quantity of water that will be produced, and is very, very necessary in the calculation that has to do with combining volume of GAY-LUSSAC'S law. All right, so let's take some examples as regard to this particular topic. Question number 1 says, what volume of steam, still remember that steam is water, but it's gaseous water, that means it's in gaseous form. What volume of steam is formed from 20 cm³ of hydrogen and 20 cm³ of oxygen mixed together? When you mix 20 volume of oxygen and 20 volume of hydrogen together, you know that it's expected definitely water will be formed. You say, what volume of steam now will be formed? Then B question says, now, what gas or gases is in excess, and by what factor or by what amount? Now, one of the challenges that students do meet in this kind of question is your ability to write a chemical equation correctly. Your ability to write hydrogen reacting with oxygen to produce water and balance it, a balanced chemical equation. If the equation is not balanced, definitely you cannot get this equation. You cannot get this question. So the first responsibility of anyone is to learn how to balance a right and balanced chemical equation. All right, so let's now solve this question. First of all, write the chemical equation. 2 volumes of hydrogen goes into reaction with 1 volume of oxygen to produce 2 volumes of water, just like the example we cited before. Put all of them in gaseous form because hydrogen is gas, oxygen is gas, and the steam is also gaseous form. That is the volume. Now the volume, look at it. It's expected the volume given actually in the equation is 20 volume of oxygen and 20 volume of hydrogen. Question now say, how many volume of water will be produced? The truth of the matter is that it was given that way, but the reaction cannot go that way. If 20 volume of hydrogen goes into reaction, definitely is half of it will oxygen contribute. That is to say, 20 volume of oxygen, 20 volume of hydrogen will require 10 volume of oxygen to produce 20 volumes of water. Look at the equation. 2:1:2. 2:1:2. So 2 of hydrogen, half of it will be 10. Half of 20 is 10. And the volume of hydrogen is the same with the volume of water. So 20 volume of water will be produced. That means that 20 volume of hydrogen will combine with 10 volumes of water, of oxygen, to form 20 volumes of steam. That is the question A. B say, which one is in excess? What is in excess there is oxygen. Oxygen, 20 volume of oxygen was given, but it's 10 that will be used in that reaction based on the equation given. Still remember, they combine in ratio. Volumes, in volumes, is not anyhow because of the number of volume of oxygen that will be given, that will go into reaction with hydrogen in order to produce water. That is the first example. Let's take another example. This is why question 1993, verse 30, number 33. Number 33. WAEC 1993, number 33. Question says, what volume of propane is left unreacted when 20 cm³ of oxygen and 20 cm cube of propane react according to the following equation. Now, good enough, the equation is being provided to you. You have been provided with an equation. In this particular equation, it's y question. So it's even easier for you. It's easier this way. But had it been that the equation wasn't provided, you have to use your hand to provide the equation, write it, and balance it. Now, with this one, let's look at it critically. Look at it. Propane, the reactant side, is 1 volume, while oxygen is 5 volumes. Carbon dioxide formed is 3, and water formed is 4 volumes. Now, we are going to ratio them in volumes and in ratio so that you know, despite the volume that was given, you know the one that actually went into reaction, and to know the one that is left unreacted. All right, if that is the case, it shows that if 1 volume of propane actually reacts with 5 volumes of oxygen, it means that if 20 volumes of oxygen is actually provided, is divided by 5, because it's 1:5. Propane, of course, 20 volume is given, but 20 volumes cannot go into the reaction. So when it's been 1:5 and 20 volume of oxygen is provided, 20 volume of propane is also given. Now you need to divide the 20 volumes of oxygen provided, divide it into 5. And when you divide it, you will have 4. 4 volumes of propane will go into reaction, into reaction with 20 volumes of oxygen in order to produce carbon dioxide and the water, 4 volume of water. So the question says, what volume of propane is left unreacted? With that, volume of propane before the reaction is 20, but the volume of that propane that actually reacted is 4 cm cube. Now, how can we now know the volume that is left unreacted? Is the volume that was given minus the volume that reacted gives you the remaining, which is 16. The volume of propane that was left unreacted is 16. 20 given minus 4 that reacted gives you 16 that did not go into the reaction. That is why a question. Let's take another example. Another wire question 2004, number 17. The question says, what volume of hydrogen will be left when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a sealed tube? What volume of hydrogen will be left unreacted, will be left when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a sealed tube? Good enough, they provided the equation for you. And with the equation, you can easily use it, ratio their volume from the equation first of all, and use the ratio to know what goes into the reaction. Now, hydrogen here we have 2 volumes, oxygen is 1. So you are comparing only the reactant based on the question given to you. Now, if you say, because that 100 cm cube, 1000 cm cube of hydrogen is given, then half of it should not be 500, but oxygen given is not up to 500. Being that oxygen given is not up to 500, use the oxygen as the determining factor. Oxygen will now be your determining factor in the sense that 300 cm cube of oxygen has to go into reaction with ×2 of its volume, which is 600, because hydrogen is ×2 of volume of oxygen. That means 300 × 2 will give you 600 cm cube of hydrogen that actually went into reaction with that particular 300 cm cube of oxygen. If that is the case, the question says which volume of hydrogen is left over. The leftover of hydrogen will not be 1000 cm cube minus 600 cm cube that actually went into reaction, and the answer will be 400. I hope you are following. So the question on GAY-LUSSAC'S law of combining volume, there is actually not difficult, but the issue there is to get the chemical equations, write a balanced chemical equation. With that, ratio their volumes, and you can able to use what is being given to you to know what actually went into the reaction, know what is remaining. Let's also take another question. Now look at this question carefully. 25 cm cube of hydrogen was packed with 20 cm cube of oxygen. 25 cm cube of hydrogen was packed with 20 cm cube of oxygen at atmospheric pressure. Now, what is the volume? What is the total volume of the residual gas at room temperature? What is the volume of the residual gas at room temperature? Still remember, the question still carries hydrogen and oxygen. That is the beginning point. And with that, you will now ratio their volumes and know what the residual gas is in the particular question given to you. All right, let's take a look at it and let's get it solved. We can see for the fact that he said at room temperature, definitely the temperature is below the boiling point of water. It's less than 100 degrees Celsius, meaning that the product should not be steam. It should be water. It should be water. It should be liquid. All right, from the question given, we will observe that two volumes of hydrogen actually went into reaction with the 1 volume of oxygen as usual, and the product produced will be 2 volumes of water molecule. All right, before the reaction, before sparking, the question given is that 25 cm cube of hydrogen was provided and 20 cm cube of oxygen was also provided before sparking, before it was exploded. Now, on exploding, look at it. What you're going to do, look at the ratio once again. Hydrogen is 2 cm cube, is 2 volumes, sorry, while oxygen is 1. Now, you check if you are to say that 25 cm cube of hydrogen goes into the reaction. That means half of it should be that of the oxygen. And if you use oxygen as the reference point, that means times 2 of it should be 40. But the question provided is more than 40. It's not up to 40, that of the hydrogen. Hydrogen is 25. Oxygen is 20. So you have to use hydrogen as the reference point, as the determining factor. 25 divided by 2, because it's hydrogen, half of it is oxygen. So half of hydrogen will be oxygen. Half of 25 should now be 12.5 cm cube. So on sparking, on that explosion, when it's exploded, it's actually 25 cm cube of hydrogen exploded with 12.5 cm cube of oxygen. Now, question says residual gas. That means gas that was remaining after sparking. Residual gas after sparking. What is remaining? After sparking, we can easily deduce that out of the 20 provided, 12.5 exploded with hydrogen. So the residual gas there now is 7.5 cm cube, 12.5 cm cube, then of hydrogen exploded with that of the hydrogen. So the residual gas after sparking is 7.5. Therefore, the total volume of residual gas left at room temperature was 7.5 cm cube of hydrogen. You get what I said? 25, half of 25 is 12.5. So out of the 20 provided, 12.5 exploded, sparked with that of the hydrogen when they reacted together. Then 7.5 was left after the explosion, after sparking? And that is what the question required of you. All right. So far, we have discussed the GAY-LUSSAC law of combining volumes, and we have treated or discussed some examples on that. With what we have done so far, I would like you to handle some of these wire questions in previous exams. You are to determine the volume of residual gas once again when 20 cm cube of hydrogen was packed with 15 cm cube of oxygen, and the resulting mixture cooled and the resulting mixture was cooled or even in a cool temperature. All right, WAEC 2009 verse number 4, WAEC question 2009 verse 4, number 4, as the case may be. Number 2, if 40 cm cube of carbon dioxide were mixed with 30 cm cube of oxygen, question now say calculate the volume of carbon dioxide produced. Which reactant is in excess and by what much? Or by how much? And by how much? Now, how many was in excess? Then lastly, of that particular number 2, what was the total volume of the gaseous mixture at the end of the reaction? 2009, number 8. The last question you have to take is WAEC question 1997, verse number 7. Okay, hydrogen reacts with oxygen according to the following equation. Number 1 and number 2 equation was not provided, so you have to use your hand to provide the equation and work accordingly. All right, thank you for being with me, and I want to believe that you enjoyed the class. Thank you, and meet you next time.